Welcome to another problem solving session. We're discussing the just concluded first round of the NMC Senior Mass Olympiad, National Olympiads in Nigeria. My name is Mesomachi, Meso for short. So we'll be talking of the next two geometry problems in the exam. That's number 28 and number 29. So we're given that ABCD is a square with side length 8 cm. Now let's see. So we're using this symbol to denote the area of a polygon. And now want to find which of these triangles, which of these areas rather in the options is equal to the area of ABE. That's for number 28, and then number 29, which of the areas in this option, either none of the above or A to D, is equal to the area, is equal to twice the area of triangle DEH. So this is quite interesting. So let's start this question. So a quick look at this. What's the first thing we can find, the first area we can find? And before we move on, these equal strokes imply that these line segments are equal. So we have AE is equal to ED. EF is equal to FB. FG is equal to GC. And GH is equal to HD. So let's let me just erase that. So just for those that don't really know. So now the first area we can find, what's the easiest that we can find? And I believe we all will agree that it's ABE. ABE is the easiest area here to find. Why? Because in the square we know that all the angles are equal. So this angle here is 90 degrees. The side length AE, since it's half the side of the square, is going to be 4 centimeters from the question. So we can just use, let me just write 4. AB is 8. So we have that the area of ABE, we can quickly use a formula for area of a triangle. Half base times height. So that is half into 8 times 4. That is equal to what? 16. So I'll just put my 16 here to show that I've found the area. Okay. So AB is 16. Now, I want to find the height of this triangle. So let me call it H. Because BFC looks like the next easy triangle we can find. So I want to find the height of this triangle BFC with respect to this base BC. So how can we do that? One of the quick things we can see is that we can complete the height, we can extend the height to meet the other side. So let me call this the foot of this point, let me call it X. And let me call this point here Y. Okay. So now, one of the things we can see is that this angle here is going to be 90 degrees. Why? Because these two opposite sides of a square are parallel. So this is going to be 90 degrees. Okay. Now it means that I just created the rectangle ABXY is the rectangle. So it means XY is equal to AB. Opposite sides of rectangle are equal. But we already know AB to be 8. So XY is 8. Okay. So it means from F to Y is going to be 8 minus H. Now, last thing we know is that opposite sides of rectangle are parallel. So it means AB is parallel to XY. Now we can see two similar triangles coming out. So in case you can't see it in the diagram, we have something like this already. This point E, A, this point Y, this is F, and this is E, this is it. So I have this, two lines are parallel. This angle here is 90 degrees, this angle here is 90 degrees. and then we have that this is equal to this. So since these two triangles are similar, that is triangle ABE is similar. So this symbol here implies similarity. It's similar to triangle YFE. And well, denoting similarity of triangles, you call the corresponding vertices together. So you can see that the angle at A is 90 degrees in AB, and the angle at Y in YF is also 90 degrees, and so on and so forth. Okay. So it means we can find the scale factor. So it means AB, we have AB over YF is equal to BE over FE. Now we can complete this equation. So AB is what? Let's put AB is 8. YF is what? 8 minus H. BE over FE. We can see that BE is twice FE from the question because F is the midpoint. BF is equal to FE. So this is just 2. So we can quickly solve this. Just cross multiply. So be 16 minus 2H. And so we have H equals to 4. So a quick solving of this will give H is equals to 4. So you can do that on your own. So H is equal to 4. So let me erase this. So H is 4. Okay, so it means we can find the area of triangle BFC now. How do we do that? So I'll just erase some of the things we don't know. You can always pause the video and take note of the things that I'm erasing before I erase them, in case you really need to follow it better. So the area of triangle BFC is what? Half BC times H. BC is just the side of the square, that is half into 8 times H, which we got that H is 4. So this is 16. So BFC is 16. So BFC is 16. Okay. So, I mean, in the exam, one can quickly, choose option A and move on. But I want us to find the area of, all the shapes here. That is ABE, BFC, CGD, DHE, and EFGH. Okay. So BFC is 16. Now, what else can we find? We want to find the area of DGC. But to do that, we need to find these heights. So let me call this H1, H subscript 1. So that's different from this other H we used. So how do we find this height H? Okay. So one of the quick things we can do is to find, we can extend it to meet this side here. Now we know that this angle here is 90 degrees. So it means sum of angles in a quadrilateral, which is 360, will force this angle here to be 90 degrees. Okay. So it means you have a rectangle again. Okay. So let's just call this point P, and let's call this point here Q. Okay. And now, to find H1, we need to find, since this is a rectangle, we know that QP is equal to XC. And from the same idea we used with similar triangles, we have that these two triangles here are going to be congruent. So that is, since this angle here is equal to this angle, okay, this side length here is equal to this side length, and this angle here, which is 90 degrees, is equal to this angle here. So we have that triangle GFE FQ is congruent. This sign here means congruent to triangle GCP by what? Angle side angle ASA. So this is the criterion I'm using, because this angle here equal to this angle, this side here equal to this side, and this angle here is equal to this angle. Okay. So what's the next thing we can do? It means that this length from Q to G, so let me just erase some things here to make my diagram neat. So it means from Q to G is also going to be H1. So I'll also put my H1 there. Okay. Now what else can we get? So it means XC is going to be 2H1. That's H1 plus H1, because opposite sides of the rectangle are equal. So 2H1. So we just need to find BX. How do we find BX? We can find the length. We can complete our rectangle, the other rectangle we used before. So this point was Y. And we got that these two triangles, the ratio of similarity is 2:1. That is for triangle ABE. Like 2:1. Similar to triangle YFE. Okay. Now, since this whole length here is 4, it means this length here is going to be 2. So this length here is 4. This is going to be 2. Okay. So let me just. So it means this length here is 2 and this length here is 2. Now, opposite sides of a rectangle are equal. So this length here is 2. So I have 2 plus 2H1 is equal to the side of the rectangle of the square, which is 8. So I have 2H1 is equal to 6, and we have H1 is equal to 3. Okay, so that's good. So we have that this is 3. Okay, now we know the base of the we know the base with respect to this height in the triangle. So let me just erase some things here. Can we pause the video to follow better? Okay, so now we know the base, like from here to here, the side length CD, which is also 8. So it means the area of triangle D. Okay, let me just start. The area of triangle CDG equals to half into 3 times 8. That's half base times height. So this is just going to be 12. So the area of triangle CDG is 12. So this is 12. Okay. Now what else can we get again? Now we need to look at the triangle EHD. Okay, triangle EHD. So to do that, recall that we got that these two triangles are congruent. So let me just use a different color here to box this. We got that these two triangles are congruent, right? So it means that this side length here is equal to this side length here. But this side length, that is CP, is equal to XQ, because opposite sides of a rectangle are equal. So it means this is going to be half the height of this triangle here, which we earlier got to be 4. So this is going to be 2, 2. From here is going to be 2. From here is going to be 2. That means CP is going to be 2. So let me just put that. CP is 2. Okay. And so to get the height of EHD with respect to EH, so let's just drop an altitude. So this time around, I'll use a different alphabet. So let's say M, maybe for Mesomachi, for my name, okay? So let's say we use M for the height here. M, okay? So my diagram is a bit messy. So let me just erase some things to free space, to create some space. So we use M, okay? Now, since this is the altitude, so this is 90 degrees. This is also 90 degrees. Since this angle here is 90 degrees, it's going to force this angle to be 90 degrees. So we created the rectangle again. So let me just bring in some new points. So let me call this point capital letter R, and this point capital letter S. Okay. So if you look at triangle DHR and triangle GHS, we see that this angle here, the angle at H is equal to the angle at H in both triangles. So the angle at H is equal to the angle at H. We see that the side length GH is equal to this side length. Sorry, this is so speed. We see that the side length DH is equal to the side length GH as given in the question. And what else again do we see? We see that the angle at S is equal to the angle at D. So the angle at D here, which is the angle at R here, which is 90 degrees. So the angle at R is equal to the angle at S, which is 90 degrees. As this angle here is 90, this angle here is 90. Okay. So what can we get from this? Okay. We can see that these two triangles are congruent by angle side side. Sorry, angle side angle. As you can see here, angle side angle. Okay. So it means that this length from H to S is also going to be M. So let me erase some things. So you can always pause before I erase, so I can follow it better. So let me just fix what we've gotten. So this side length here is M, this side length here is M. And recall that we got that from here to here is 2. So it means from here to here is 8 minus 2, which is 6. That is PD is 6. Okay, so since opposite sides of a rectangle are equal, we have 2M, that is M plus M, is equal to 6. So M is equal to 3. Okay, so we can quickly put our 3 here. But now, since this is half the side of the square, which is 4, so this is going to be 4. So the area of EDH is going to be half base times height. That is half base, which is 4, times height, which is 3. So the area DEH is equal to this, which is equal to 6. So this is 6. Let me just use red. If red is your favorite color, you can always indicate in the comment section. So this is 6. Okay. So now, that is all the solving we can do. We don't need to do solving to find the area of EHGF. And why? Because we can now find the area of EHGF by adding the areas of all the triangles and subtracting it from the area of the square. So let's do that. Okay, we'll just erase a lot of things quickly. Let's have a diagram clean. So let's fix 16, 16, 12, and 6. And we call this, let's call this area A1. So A1 plus 16 plus 16 plus 12 plus 6 equals to the area of the square, which is S squared. That is 8 squared. So I have A1. So 16 plus 16, that's 32. 32 plus 12, that is 44. 44 plus 6, that is 50. So equals to 64. So I have A1 is equal to 14. Okay. So this is 14. So you can just quickly check. So 14 plus 6, 20. 20 plus 16 plus 16, that is 52. And 52 plus 12, that is 64. Okay, so that's it. So that's how we get, So now I've gotten all this. So we can quickly put, so 2 times DEH, this is 12, and EFGH is 14. So now we see that the answer to 28 is A. Okay, now they say which of the following is equal to 2 times DEH. So now what is DEH? Is 6. 2 times of 8 is 12. Okay. So let me just erase these things down here. I like leaving the board almost neat towards the ending of my solution. And now ABE 16, BCF, what is BCF? 16, CDG 12, EFGH 14, and we see that is CDG. So the option is C. Okay, and so that's a good place to stop for today. So I'll leave you with a question. So my question, the first question I have for you guys is, what if we're not given the side length of the square? Is this 8 cm necessary? So is the 8 cm necessary? So you can just think of that, and you can share your ideas in the option. So don't send me an email, because I want you guys to think about it on yourself, and you can discuss it in the options. And then the second question I have for you guys: what if the square was a rectangle? What if we made it a rectangle? Like, what if we started from a rectangle, and then we picked half this side, and then we drew it to this point, and then we picked half this side, and then we drew it to this vertex, and then we picked half this side, and then we drew it to this vertex, and then we picked half this last side, and then we drew it here. Okay, so what if it was a rectangle? Or what if it was a parallelogram? So what if ABCD was a parallelogram with no dimensions given? Is the question still valid? So don't mind my handwriting. It's just I'm trying to write fast. So is the question still valid? So I want you guys to think about that, and that'll be all for today. So see you guys in the next video.